Hi, everyone, and welcome to this special presentation hosted by Data for Good and by Women in Data. We're thrilled to have some amazing presenters this evening to talk to us about AI and ML and the use for tracking mental health during the pandemic. So for those of you that may not be aware of Data for Good, just a few opening comments. So we're a group of passionate, socially minded, curious volunteers that use our skills in data science and analytics for social good. Our aim really is to help nonprofit and social organizations harness the power of data to leverage their impact in the community. And Data for Good in Calgary, we're one of 9 chapters across Canada with thousands of members, and we've worked with many nonprofit organizations. And we really encourage you to spread the word to your friends, wherever they might be across Canada. So in Calgary, we've been going since 2013. Over 1,700 members at this point. We work in a number of different ways. We have larger events called datathons, where we partner with larger organizations with a lot of data. This year, we're partnered with the Calgary Homeless Foundation, and hopefully we'll be doing a datathon with them at some point in the fall. We work with smaller organizations on smaller projects through our data core, data ambassadors, volunteers that help on those projects that can take a few months or that sort of thing. And then, of course, we have our regular monthly meetups. So please join the group and pass it along to your friends on Meetup. Our Twitter handle is at DataForGoodYYC. And our national website is DataForGood.ca. So just a brief outline around Data for Good. So this evening we have actually 3 presenters. So in our write-up, we've told you about Alana and Dan, who will be going into their research and the amazing work that they're doing with AI and machine learning. And we'll be getting to those presentations shortly. But what we really wanted to do was to try to level set around this whole issue about mental health and about the dramatic impact that the pandemic is having on society, on our community, and all of us. And we're very fortunate to have with us Robin Romano from the Calgary Distress Center. So Robin will kind of level set us a bit from a really on the grounds perspective in terms of the calls and the text and other ways that people are reaching out to the Calgary Distress Center in this time of the COVID. So Robin, welcome. If you can, there you are. If you can unmute yourself, and if you want to share a screen, that would be great.
Awesome, thank you so much. I'll just get that screen up there. And there we go. All right, so thank you so much for having me to get to join in this evening to just speak for a few minutes about what we're seeing on the ground level. My name is Robin Romano. I'm the Director of Operations at Distress Center. I oversee our organizational performance area, which is our area that focuses on our data as well as all of our service delivery programs. We have a very small data team of 1 person. Looking at data from about 122,000 contacts a year. So we at Distress Center sit on a huge minefield of data, and we really look at our data in being close in alignment with what really the vision of Data for Good is that our data is used as a social planning tool and a tool for social good. Our data does much better in the hands of policymakers, funders, community organizations than it necessarily does sitting with us. So it's really exciting to get to be here and kick off this meeting today. I think Distress Center's really first dive into looking at our data and really seeing what does it mean for what's going on at ground level. Calgary really started with a datathon. So I don't know if there's anybody in the meeting today that was part of the datathon that was done with Distress Center. But if you were, thank you so much. And thank you so much for all the work that happens on the datathons. I know our data's been used in a number of them, including the one that ultimately benefited us and kicked us off in a direction. So Distress Center has a mission of providing compassionate, accessible crisis support to enhance the health, well-being, and resiliency of individuals in distress. So for those that don't know anything about Distress Center here in Calgary, we do provide 4 core services. So the first core service is our crisis services. So that's 24-hour phone and email, daily online chat, suicide prevention. We're one of the pilot sites for the Canadian Suicide Prevention Service across Canada, and our Connect team, which is a daily text and chat service for youth. We do have in-house professional counseling. So for issues that may need more support than just over the phone, somebody can come in and see a counselor one-on-one. That was pre-COVID times. I still talk pre-COVID times. Now all of those are done via Zoom and phone sessions. And then our 2-on-1 information and referral, which really looks to connect people with the community resources. I think for those that have worked with some of our data with Data for Good and datathons before may be most familiar with the 2-on-1 data. I'm not going to dig into that too much today and really highlight more of what we're seeing on the crisis lines. But 2-on-1 is provided by phone, chat, and text 24/7. And then we have our coordinated access and assessment, and they work out of Source. So they are our offsite team that works predominantly with the imminently and chronically homeless population. And I'm sure a lot of their data is what you'll be using and working with in that upcoming datathon with the Calgary Homeless Foundation when it happens. So as I said, we sit on a number of different programmatic data that comes in daily, as you can imagine, especially with 24-hour contact center operations. So as we started to really look at data years ago, we started to look at what are the top topics and themes and conversations that we really need to be paying attention to, which include one-off big disasters when they start coming in. So we really did start tracking contacts related to the COVID-19 pandemic, with our first contact coming in on January 26th. So our first contact for COVID did come in on January 26th, but it really became a top issue the week of March 15th, which was 4 days after the World Health Organization called a global pandemic. So although I'm not sharing the 2-on-1 data today, I will just say the top things that we are seeing on 2-on-1 are the communicable disease control, information lines, emergency financial assistance, and emergency food. And so when I quickly mentioned there are the top things that we're seeing on 2-on-1, when I do show a quick slide showing how our volumes are, I think it will make sense of why we've seen a higher volumes with 2-on-1. And with crisis, it's really been about a lot of feelings of anxiety, depressed mood, loneliness and isolation, and family relationships. So this is just in the next couple slides, it will show the trajectory of how some of our top 10 issues have changed over time. So again, as I said, January 26th was when we got our first COVID contact. So we're calling that week 1 in this report that I'll just show you a few slides from, all the way to the most updated, which was June 6th, which was week 19. So some of the trends that we're seeing that really do relate to that mental health aspect are we're seeing an increase in the number of high risk crisis and 2-on-1 contacts, an increase in the number of contacts requiring emergency intervention, which relate to a 20.4% increase in suicide-related contacts from January 26th to June 6th, comparatively to the same time period last year. And so some of this data is being used to help inform conversations that are going on at community tables regarding issues around mental health, loneliness, isolation, and the increase in suicide that we are starting to see. So as I said, I'm not going to share too much about 211 data. However, if you are really curious on what we are seeing on 211, we have, again, thanks to a lot of our learning with this on our 211 website, which is ab.211.ca. We do have a Power BI dashboard, which is updating daily with data. The only thing just before I get into the crisis where I did want to identify is you can see really the volume of calls and contacts that we had for 211 and really that spike at the start of the pandemic when people really had their concerns around how are they going to meet their basic needs. I think as we start talking about mental health, I think it's important to really reflect on what did we see at the start of this pandemic. And really a lot of that did have to do with financial assistance. Where am I going to get food? I don't know if anybody that's at the meeting today knows, but the food bank had to close down for a few days to figure out how they were going to provide service for the community under these new ways of working. So we definitely saw increases there in terms of the in terms of meeting basic needs. Now, when you look at our crisis contacts, we actually saw a little bit of a dip in contacts on the crisis lines at the start of the pandemic and really have not seen an increase yet. There's a lot of speculation and a lot of conversation of why that might be. We're not the only organization that's seen that. It's quite similar with other disasters that we've had, the 2016 fires and the 2013 floods, is that at those initial phases, people are not quite thinking of their mental health needs and aspects yet when they're so focused on meeting those basic needs. We are anticipating, though, we've been stacking up in our own internal center for both our crisis counselors and on our crisis lines for those increases in contacts that we know are coming, as are other community organizations that we work with. So here just really kind of shows that week 19, so that up to June 6th, really what the top issues we're seeing across all of our crisis contacts are versus what we're seeing on ones where COVID is marked, because it's been explicitly said in the contact that they're calling related to COVID. So you can see that anxiety, depressed mood, isolation and loneliness are some of those top concerns that we are seeing, followed again by some of that long-term mental illness and suicide ideation. So again, looking at the top 10 issues on our COVID-related contacts, one of the things that I just think is really interesting, and I wish we had a research team. I know I was talking to Jeff last week and said, are there any volunteers with Data for Good that might want to jump in and dig into this with us a little bit, with me and my one-person small team? But from what we know with research that has been done with our data previously on the recession, is that some of what we're seeing here, especially around anxiety, makes sense, is that a lot of factors go into the fluctuations that we're seeing with what we're seeing on the front lines, is that sometimes, especially with anxiety, the anticipatory of an event creates a higher and heightened level of anxiety than the event itself. So we definitely see that when you look at that week 5 and 6, really having that spike of anxiety being the main issue on a contact of being 70%. Then we look down again at loneliness and isolation starts creeping up as, you know, people are more disconnected from their day-to-day life and more disconnected from the people in their life and those physical aspects, which we know is having a serious impact on the mental health of the citizens of Calgary. And then again, if you just take a comparison on the top 10 issues of all of our contacts, again, you see that anxiety and depressed mood really high up there, and isolation and loneliness has dropped a little bit comparatively to it being the main contact along with the COVID. Then we see again that suicidal ideation and long-term mental illness. I think the biggest thing that we've seen so far is, although we haven't seen a spike in contacts yet, we know it is going to be coming as more of those basic needs have been met and business back to usual a little bit more, but it's the complexity of what we have been seeing come in. So we have been seeing more contacts related to anxiety, depression, loneliness, isolation. And then for us, the one that we've really been starting to dig into is that 20% increase in contacts related to suicide. Our last number of years, we've had increases from the previous year related to suicide. So to see a 20.4% increase already this year tells us the state that a lot of people in our community are in, and really what we can be doing with our data to be able to tell the story, to be able to support initiatives that are going on within Calgary to hopefully help support what our community is going through and how our community is banding together during this time. I was telling Jeff I didn't have time to put it in the presentation because I just did get these stats before this, but I thought it was a really interesting to share as we move into talking about AI. Is that our Twitter engagements have been at a 349% increase, and especially visits to our Connecting website, so our website for youth where they can come and search out information for themselves if they're not quite comfortable talking to somebody yet, have really seen an 81% increase from the same time period of last year. So I think one of the things that's really important to notice, and as we're talking moving into the AI, is how are people using these online modalities and how can we really learn from them to better support our community members who are struggling with mental health. So I'll just kind of tie it up there. That's kind of what we're seeing so far. Like I said, if you're interested in seeing updated daily data, check out the 211 Alberta website, and don't hesitate to reach out to the Stress Center if you're curious. We are producing a data report weekly. We do believe in open data and data sharing to really help create change within our community. So thank you, Jeff.
Great. Thanks, Rob. That's fantastic. And Distress Center has been amazing in the use of their data. Robin, there was one question for you. Do you have any information saved about the gender and age of people who contact the Distress Center?
Yeah, so we definitely have all of that. I didn't get to throw it up in the presentation. So one of the things, Jeff, that I could maybe do for you and the group today, because I know you were going to send out the PowerPoints, is that actually our Word document of our report might be a better thing to send along to everyone, because it does give a breakdown not only of the issues that we're seeing, but the modalities of how people are reaching out. So what percentage are choosing phone, chat, text, as well as some of the age and gender demographic information.
Great, great. Thanks a lot. We can certainly pass that along to the folks. Great. So then we'll have our next presentation. So we have Alana, who's at the University of Alberta, yeah, we're happy to have you here from Amy, and I'll kind of let you introduce yourself and your background and kind of dig into some of the really interesting technical details about AI and ML.
Yeah, sure. So I'm Alana Fish. I'm an assistant professor at the University of Alberta. I'm split between psychology and computing science. My background is in computing science, but during my PhD, I started to work on brain imaging data, which took me into the psychology realm. So most of my work actually has been on relating the language models I'll talk to today to how brains process language. I'm not going to get to talk to you about that today, but actually there's lots of videos of me talking about that in other scenarios. So I'll just share my screen with you here. We can get started. This is a big departure for me, this new project. So I'm actually going to talk about some of the language modeling that is more my bread and butter. And then after me is Dan Lizotte from the University of Western Ontario, who will sort of cover some of the work that he's done in this area. So one of the things that inspired this work was some of the news stories that we had seen early in the pandemic that talked about buying habits during coronavirus. So you might have seen some of these graphs. I'll show them to you now. First of all, people grocery shopped a lot very early in the pandemic. So there was sort of this feeling of scrambling for food and toilet paper, as you may remember. And so people really felt like there was a need for them to stockpile food. You may have seen some of the news stories about people buying entire grocery shopping carts worth of meat and so on and so forth. And so that the question was, is there similar sorts of trends on Twitter? And so some of the other things that they saw in the shopping data were these are the sales of coffee and alcohol. So people have to make their own coffee at home if they're working at home. So I think more people were, that's where this coffee trend comes from. And maybe the alcohol trend is coming from people not going to happy hours, or maybe people just felt like they could use a drink now that they're home with their children without childcare. So we were interested in thinking about the sorts of trends that we could see as the pandemic progressed, and what those trends might tell us about mental health. And so what I've told you about so far in sort of things that you could think of as being indicative of negative mental health outcomes. But one thing we were also interested in is the idea that there might actually be positive habits that we could see using Twitter data. So this is a Google search trend graph, and it shows that over time, people actually became really interested in baking bread. And so we don't know this for sure, but it seems like that sort of hobby, taking up a new hobby, finding a new community of people who are also trying to bake bread might be satisfying to people, and it might actually improve their mental health. And so these are one of the sorts of things we were interested in exploring. This is the Amazon search data for a similar period, and you can see people are searching for flour and yeast online, because you may know if you tried to do any baking recently, actually flour and yeast were quite hard to come by for a little while. It seems to have improved now. So we wanted to know, is there a way to see how people are feeling on Twitter? So certainly we can tell if they're happy or sad on Twitter, but we were also interested in what are the sorts of things that seem to be driving that happy or sad behavior. So are people, how are they coping with the pandemic? In the early days, there was a lot of frantic shopping. It probably didn't make people sort of maybe created feelings of frenzy. And then later on, these people took up new hobbies like baking bread, or maybe gardening was another one I heard of. People learn how to sort of cope better. And so our question was, can we find these sorts of patterns of behavior that might be associated with the curves of the pandemic? And so across many different cities, if we align the pandemic curves, sort of the onset of the pandemic in each one of these areas, can we see that certain behaviors sort of independent of the onset of the sort of independent of the actual pandemic curve in that area, these sorts of habits seem to lead to happier tweets. So that's the working hypothesis, and we're a ways away from actually showing whether or not that's true, but that's sort of that was the inspiration for this project. So I'm going to tell you first about how we build computer models of language meaning. So in order for us to do what we're talking about now, we need to be able to tell what a tweet is about, and so we need to be able to understand the words in a tweet. And so that's what I'll talk about today, the way that we represent word meaning, as well as how we work from that individual word meaning up to something that's more higher order. And then Dan's going to talk more about the actual project itself, how we can use word embeddings on social media data, and some of our very preliminary work on the COVID-19 and this mental health outcomes that we've been talking about. I should say also that Rumi Chinara from New York University is not here today, but she's also one of the PIs on this project. And we recently, I should also say, we received funding from the Canadian Institute for Advanced Research, or CIFAR. So we're very happy to have them supporting this work. So you might not know it, or maybe you do. I mean, I think if you work with data, you probably do know that language is extremely hard for computers to understand. You're so good at understanding language that you have forgotten how hard it is. But it's extremely hard to get computers to understand language the way that we do. And at this point, I would say impossible, but we're working towards it. And part of the reason behind that is that language can be very ambiguous. So here's a few funny examples. So juvenile court to try shooting defendant. So this could be try in the sense of the legal sense, but it could be try as in attempt. So juvenile court is going to attempt to shoot the defendant. That is not the correct interpretation of this headline, but certainly an interpretation of this headline. Hospitals are sued by 7 foot doctors. So possibly there are 7 foot doctors who are doing the suing, but it's also possible that a group of foot doctors who are 7 feet tall got together to do the suing. And then maybe something that's a little less interesting, but more common is that we see Alice saw Bob with a telescope. So is Alice looking through the telescope at Bob, or does Bob have in his possession a telescope? And so you can see that these are some of the ways that language is tricky. And so these are also some of the ways that computers become confused with language. And that's part of why it's hard for us to build computer models of language. So I'm going to, because this is a hard task, I'm going to start at a very simple level. So we're going to talk about the meaning of single words. And partially that's because the concepts that surround the meaning of single words can kind of be extrapolated to higher order meaning. We could also start by representing meaning below the word level. So the suffix ed or ing, those carry meaning. And so we might want to model those pieces. But today, to keep it simple, we're going to just deal with single words as if they're discrete entities. It's a little more intuitive at that level, and so it's a good place to start. So I usually do this as an interactive question, but since this is a virtual talk, I'll do it myself. So I usually say, can you name for me something that's like an orange? And people say lemon, tangerine. Somebody once said ball, which I thought was very interesting. It's the only time I've ever had a non-fruit thing said at one of my talks. People often say things like apple, people say banana. I've never had anybody say car. And I've never had anybody say sandwich, even though sandwich is something that people eat. It's an edible thing. And so the question is, why don't people say these words when I say what's similar to an orange? And that's because each one of us has in our mind a representation of how the world works. And we understand that orange is a fruit. And if I tell you, please tell me things that are similar to an orange, you would probably not go outside of the fruit category. And even when I do this example, people often actually tell me other kinds of citrus fruits like lemons and tangerines and mandarins and so on and so forth. And so we can think that in your head, you might have some representation of word meaning. And so perhaps let's pretend for a minute that you only have 2 dimensions of word meaning in your head. So on one dimension here, we have sweetness, and on the other dimension, we have grows on a tree. So our fruit are sweet and they grow on trees. And so we see them in the upper right-hand corner of our graph. Now, sandwiches and cars do not grow on trees, sadly. Wouldn't it be nice to get a car from a tree? And maybe sandwiches are slightly more sweet than cars. Certainly cars aren't very sweet in a food sense. So cars and sandwiches here exist on the lower left-hand corner. So you can see here that words that are similar are clustering together. And this isn't a very complex model of meaning. And so car and sandwich have been put together even though they're not very similar to us in the real semantic world. And so that is a very simple vector space model of semantics, also known as a word embedding. So actually what we have is that in this semantic space with these 2 dimensions, each one of our words has associated with it a list of numbers. So since this is a 2-dimensional space, there's 2 numbers. Sandwich has the numbers 0 and say 0.03 as its X and Y coordinates. So every word in the space has a set of numbers associated with it. So banana has some numbers, apple has some numbers, orange has some numbers. But because we have this 2-dimensional space here, we weren't able to distinguish, tell the difference between a car and a sandwich. And so here we have a 2-dimensional space, but what would allow us to better distinguish between items would be to have a higher dimensional space. So we take these vectors that have only 2 numbers in them and we make them very big, so much longer. So on the order of hundreds of dimensions. So one of the popular word vector models is around 300 dimensions. And the way that this works is that words that are similar will have similar vectors. So just like it was in the 2-dimensional space, when we move up to high dimensions, if we were to correlate the word vectors, words that have high correlation would exist at similar points in space and they would have similar meaning. And this makes sense if you think of synonyms. So a synonym, this is a list of synonyms for the word beautiful. So pretty, lovely, handsome, attractive. Synonyms for big are enormous, huge, immense, and gigantic. And so we can think of these words would cluster together in semantic space. And one thing to note here is that since these words are synonymous with each other, they are also probably used in similar contexts in text. So if I looked for all of the different places that somebody used the word beautiful and somebody used the word pretty, there would probably be a pretty strong overlap about the kinds of words people used around the words beautiful and pretty. So can we use that idea that context tells us something about word meaning in order to model the actual meaning? So that's the idea behind these vector-based models of semantics. So being people who like data, we wouldn't want to have to sit down and decide what the word vector for every word should be. Rather, we would like the data to tell us what the word vector should be. So the way we do this is we use a large collection of text, billions of words, in order to detect these patterns of co-occurrence of words, and those co-occurrence patterns tell us something about language meaning. So what we do is we train models using the words that we observe together in a large collection of text. So together we can define in many, many ways. They could be just within the same document, or if it may be the same web page, maybe it needs to be within the same sentence, maybe it needs to be within 4 words. And what people tend to do is this last case where we look within 4 words of the word we're interested in. So we tend to see maybe around the word pretty, we see girl or sunset, or I don't know what else. And so the sorts of words we see around the words pretty and beautiful will probably be similar. And so one of the popular machine learning models for word meaning is skipgram, or word2vec, you may have heard it called that. And it is a neural network. And this neural network's task is to predict the context words given a central word. So if I tell you that the central word is banana, this particular neural network is trained to predict with high probability the sorts of words you would probably see around the word banana. So maybe the word 8 or the word yellow might be around the word banana. And so we would want to predict high probability some of those very commonly occurring context words. And so you can imagine that if we had a model that did this, if it's going to predict probable context words, if 2 words are similar, it would want to make a prediction of the context words that's also similar. And so the way we train this model is by gathering millions of web pages and generating trained data, which is just pairs of words. So the central as well as the context words that we see nearby. So actually skipgram under the hood is a very simple neural network. It only has one hidden layer. So that's what I'm showing here. Here on the left-hand side is X, that's the input, H is the hidden layer in the middle, and Y is the output. So the input to skipgram is what we call a one-hot vector. And so that means the central word is coded as a 1 in the vector. So every element in the vector corresponds to a different word. And only one of those elements is on, and that corresponds to what the central word is that we're currently working with. So if we were talking about the banana example, say X2 here is on because X2 corresponds to the word banana for our vector that we've set up here. And then the model is trained to create an output, which is a probability distribution over words. So we want to train this model so that the values of Y, the output values Y here, are high for the kinds of words that commonly co-occur. So we're talking about the words 8 and yellow, maybe Y3 and Y4 are 8 and yellow. And so we want those probabilities of those 2 particular values to be high. So essentially we're going to learn weights. The weights correspond to the black edges in this graph. We're going to learn those weights such that when we put in the word banana, when it goes through these learned weights, on the other side, we're going to end up with numbers so that the corresponding commonly co-occurring words will have high values. So we would like to see high values for 8 and yellow on the right-hand side here. And so in the process of training this model with all of the weights on the black edges, we end up with what we call a hidden representation for the central word. And so that really is just the values of these hidden nodes once the model's all trained up. So I put in the word banana on the left-hand side, and my hidden values in the middle here tell me what the representation is for the word banana. So these models would have, here I'm only showing 3 hidden values, but they would have 300 hidden values, and those 300 hidden values would become our word vectors. These word vectors are really, and people have been playing around with them in computational linguistics for something like 3 or 4 decades. It's been a long time. And this is a more recent finding, but one of the things that you can do is train the word vector models on subsets of data over time. So take all of the data around 1900 and train a word vector model, and you'll find that the word gay is close to words like dapper and courteous. And then as we move through time, the meaning of the word gay changes until its current meaning of homosexual or same-sex relationships. So we can see this progression of meaning over time because the way that we use the word gay has changed so much over time. And so these shifts in word meaning we can pick them up with these word vector models. Okay, so now we have some word vector models. Each one of our words has a corresponding list of numbers, a 300-dimensional list of numbers. And so the question is, what can we do with them? So we want to evaluate our word vector models. Let's say I have 2 word vector models. How do I know which one is better? So actually, people in computational linguistics have devised many ways to try to figure out which one of 2 distributional models is better. They love to make benchmarks. So there are many benchmarks available to test word vector models, and I'll talk about a couple now. So one is a data set where people actually, a set of researchers actually asked people to tell them which pairs of words are actually, how similar 2 pairs of words are. So this is the Simlex 999 data set. And essentially what they did was they showed people pairs of words like alligator and crocodile, and people would give that a rating. So how similar is alligator and crocodile? Maybe people say give that a score of 5. Cup and mug, also very similar, give it a score of 5. Potato and shoe, not very similar, so we'll give it a score of 1. And then in our vector space model, we can also say how similar are alligator and crocodile. The way we would do that is by measuring how close together they are in the space. And so we could imagine computing something like correlation and using that number here, and we would scale it so it's between 1 and 5. But you know, alligator and crocodile are correlated very highly. They're in very similar places in the semantic space, so they have a high score. Cup and mug get a 5, and potato and shoe have a smaller number. So if we have a good word vector model, we would expect to see very high correlation between the scores that people give and the scores our word vector model gives based on the distance between words in the space. Another really neat task is a word analogy task. So you probably have heard these questions before, and they're very common on language tests. Hammer is to nail as screwdriver is to, you probably guessed, screw. And so it turns out that these word vector models can solve these analogy questions as well as American high school students do on the SATs on the same questions, which is a really neat finding. So now I'm going to tell you how we actually use these word vectors in order to perform this analogy task. So if these word vector analogy, the analogy questions themselves are actually sets of words. So A is to B as C is to D. And so what we would do is retrieve the 4 word vectors for those individual words, A, B, C, and D. And then we're going to compute a particular new vector Y by taking the word vector for the word B, subtracting the word A, and adding the word C. So if hammer is to nail as screwdriver is to screw, I'm going to take nail, subtract hammer, add screwdriver. And my hope is that this new vector I compute, vector Y, is close to the true vector XD of the what would be screw in this particular example. So we're going to sort all of the words in my space by their distance to this XD. And if I get, if Y is closer to XD than it is to any other word in the space, then I get the question correct. And as a little aside, people often actually exclude X, A, B, and C from the sets that they sort by distance to Y. And it turns out, sorry, and I'll give you a few example questions from a particular benchmark that Google put together. So one of the kinds of questions that they include are common capital city. So Athens is to Greece as Oslo is to Norway. Or a man-woman relationship. So brother is to sister as grandson is to granddaughter. And so these are the sorts of relationships that we're going to attempt to solve with this idea of adding and subtracting the vectors. And it turns out that this actually works quite well. Some of the best performances are up into the high 60s and 80s. So we can split these questions into 2 types. So with pretty good accuracy, we can answer these questions with these word vectors, showing that the representations of meaning that we get out of these word vector models are close to what people would say for these analogy questions. And that means that the direction in semantic space, so it's not just that words that have similar meaning are close together. It's also that the direction of travel in a semantic space, in this high dimensional space that we've built, also encodes meaning. So moving from a masculine to a feminine word is a particular directions, and that would be similar for all of the pairs of male-female words. So to move from uncle to aunt, I want to move along this man-woman direction. King to queen is along the same direction. And so this allows us to perform these analogy tests, because it turns out that these sorts of semantic relationships are also represented in space. So this is a really neat finding, and it's actually it is actually the case that this is a function of the data itself. So it's not that word skipgram, the neural network I showed you, is somehow fancy and picking up this pattern or creating this pattern of the data. This pattern exists in the data already, and it's just that the models that we build allow us to perform these computations in an easy way and see that that relationship exists. Okay, so that was a whirlwind through a particular level of language meaning. So we talked about the meaning of individual words. So we just talked about each word means in isolation, and there's a bunch of caveats that come along with that. And for example, things like the fact that a word can have more than one meaning is not something we talked about at all, but it's definitely something you need to think about if you're going to use word vectors. So we talked about the most simple case, and of course there's tons of stuff above and below this particular level that we decided to talk about. I'm going to switch gears now and talk about semantics, at a much higher level. So now we're going to talk about the semantics of a whole sentence. By processing the individual words, we're going to be able to build or represent the semantics of an entire sentence. And semantics, sorry, if I didn't say already, it just means word, it just means meaning. So I'm going to give you a really quick rundown on recurrent neural networks. So RNNs, again, are trained on a very large corpus. So we use the same sorts of data that we use to train our word vectors. We can also use to train recurrent neural networks. And they are trained to predict. So instead of doing this, predicting the context words given the central word, RNNs instead predict the next word in a sequence. So given a sentence, in this example here, the sentence is "the students opened there." You would like to be able to predict the next word in the sentence. And so the model, in order to do this, uses word embeddings, and these word embeddings are just like what we just talked about. So you can initialize this model with the word embeddings from skipgram, for example, and that will give the model a sense of what each one of the constituent words means and their relationships sort of to each other by similarity. And then on the top here, the red vectors represent a hidden representation that exists inside of an RNN. And that hidden representation is the way that the model can remember context. Remember, so we're trying to represent the meaning of an entire sentence here. So we need to be able to build up some sort of context over words, because we need to be able to consider the words in this context in order to make a good prediction for the next word. So at first, there's no context at all. So this H0 vector is actually just randomly initialized. And then this next vector here is computed from the first word, as well as the context up until that point, and so on and so forth. The next vector here is calculated using the second word, as well as the context up until that point, so on and so forth, until we get to this final vector. And this final one vector here is used to predict the next word in the sentence. So here it gets as input the word "there," as well as the context up to this point, and its job is to predict the next word in the sentence. So the students opened there, and you can imagine that the word laptop might have high probability, and the word notebook might have high probability. So students are opening something. It could be a notebook or a laptop. And so if the model is trained well, it will assign high probability to words that make sense at the end of the sentence. Right, so this is the probability distribution over words, like we talked about. And so just like we saw before, it turns out that these hidden vectors perform very similarly, that similar sentences will have similar hidden representations. And that makes sense, because this vector is the vector that we're going to use to create this probability distribution. And so similar sentences will have similar words at the end. And so this hidden representation at this point should be similar. And so you can think of using these hidden representations to do the same sort of clustering in high dimensional space that we talked about. So if we process this on all of the sentences in our corpus and looked at which words have similar hidden representations, we would find that those words with similar representations, those sentences with similar meaning would have hidden representations that were similar. And so one of the things that's a goal in the work that we're doing is that we'd like to be able to tell if a tweet is positive And so you can think of a very similar model to what I just described as trying to predict the next word in a sentence. Instead, we might want to predict whether or not the sentence is positive or negative. And so that would be, rather than a probability distribution over the next word, now we have a probability distribution over sentiment. So is this a positive sentence? Is it a negative sentence? So I don't actually think that the student opened there is a negative sentence, but you get what I mean. And so here's actually, there's actually a very large database called the Stanford Sentiment Tree Bank. And it's a really interesting resource. It has a bunch of sentences. They're actually from movie reviews. And they are labeled at a very fine-grained level for sentiment. So here's a sentence: Roger Dodger is one of the most compelling variations on this theme. And so then each one of the nodes of this tree represents a sentence parse, which we don't need to know about, but each one of the nodes is labeled with whether the word that it corresponds to is a positive or negative word. And so most of the words in the sentences are neutral. The only one that the data says is positive is this compelling. And then they actually had people label all of the subtrees in these trees, which is an amazing data annotation task. So the most compelling variations is itself a positive sentence fragment because it has a positive node at its root, and so on and so forth up this tree to show that this particular sentence is actually a positive sentence about a movie. And so here, if we look at this next tree, the only word that's changed is least. So we changed the word most to least, and here on the right-hand side, now we have Roger Dodger is one of the least compelling variations on this theme. So a compelling is still a positive word. Everything else is neutral except for least now has been labeled by people who saw these sentences as negative. And then again, that negative actually trickles all the way up this particular sentence to the very top to say that this particular sentence is negative. This sentence is not the sort of thing you would want written about a movie that you had made. So you can sort of see how processing a data set, a sentence could, there is data that exists that tells us whether these sentences are positive or negative, and we want to be able to combine the words together in a smart way that allows us to make that prediction about whether somebody's tweet is talking about something that is a happy tweet or a not happy tweet. Okay, so this is actually where I'm going to stop. We talked about the representations of the meanings of words, and we also extended those ideas in order to talk about how we could represent sentence meaning and how we could use sentence meaning in order to predict sentiment, whether or not that sentence is positive or negative. Okay, that's it for me, and I'll let Dan take over now.
Great, thanks a lot, Alana. That was very interesting piece on there. We did have some questions, but they're somewhat technical, so I think it would be a bit difficult to kind of go back and answer those at this point. But if people want to reach out to you, I assume that they can get a hold of you and kind of ask you directly.
Yeah, sure. I have a very unique name, so it's easy to find me.
Okay. All right, Dan, you're next. Welcome from Ontario.
Thank you very much. It's very dark here in Ontario right now. I will just share my screen. Okay. Are we good? So my name is Dan, and I'm faculty at the University of Western Ontario. And like Alana, my background is in computer science, actually computing science, because I'm a grad from the University of Alberta. And Alana and I have been friends for a long time, but this is the first time we've actually had a chance to work on a research project. We've organized some other stuff, but so it's been really fun, and I'm really excited about it. So I am appointed at Western in the Department of Computer Science, and also in the Department of Epidemiology and Biostatistics. And I want to tell you about how my team and I have applied some of the techniques that Alana was talking about to some challenges in public health practice in particular, and then hopefully tie that into what we're hoping to do in terms of the analysis of COVID-19 and tweets. Just a quick content warning, I'm going to be talking about drug use and possibly death. Okay, so I'm just going to tell you briefly about a project that has been going on for a little while now that was spurred by contacts that we've been fortunate to have with Ottawa Public Health and with the Canadian Public Health Association. And it was really driven by a question that we got from an epidemiologist at OPH, Cam, who's fantastic, who was talking to us about the fact that OPH and lots of different public health organizations would really like to understand the prevalence of different sorts of issues in vulnerable populations who are subject to stigma. Stigma especially because it's difficult to reach out to those sorts of groups of people. So they were starting to think about what are some other venues besides the usual literally go out on the street and meet people, which is a great thing, but you can only do that necessarily, you can't necessarily do that all the time, or, can consume a lot of resources. And even if you want to do something like surveys to try to understand where these populations are and how to reach them because they're stigmatized, that can be not very successful sometimes. So some of the technologies that we use to try to see if we could help with this task were some of the representation techniques that Alana was talking about. The sort of next goal for that project is to bring an interactive visualization component to it. So the first part of my little mini talk is going to be about that project. And then after that, I'm going to talk about COVID-19 and mental health and bring it back to what Alana was talking about at the beginning. I'm going to frame it as a little bit more as epidemiology. I think there's lots of useful ways to think about this phenomenon that we're seeing. And so I want to give you a taste of how an epidemiologist might think about what it is that we're looking at. Okay. So this is my team from this last project. I just wanted to put that up there very quickly. Lead is Brent over here on the right. He's a PhD student with me. And these lovely folks are from the different organizations that have supported us. So when I give this talk in different settings, sometimes I kind of have to explain what Reddit is. And I'm sad that I can't do hands, I guess, here. I'm guessing that a lot of you probably are aware of Reddit. I was actually not super aware of Reddit except for the name. But if you're not, all you really need to know is that Reddit is a social media website that is sort of organized around communities of common interest of people who kind of get together and just post about stuff and comment and discuss different things that are relevant to that community. And there are lots of, so Reddit's organized into subreddits, and they can be around like geography, for example. So this is the Ottawa subreddit, which has a spoof post about, so like OC Transpo had this ad where they were like trying to teach people how to use their bike on the bus, and then somebody kind of remixed it into how do you bring your raccoon on the bus. So anyway, it's Ottawa humor, I don't know. So that's one sub-community. And here's another one. So /r/opiates is a subreddit that is composed of a collection of people that includes people who use drugs, people who are interested in harm reduction, people who are interested in public health and population health. And there's a sort of ongoing discussion in this subreddit around all sorts of topics related to opiates in particular, but kind of drug use a little bit more generally. And we started looking at this because one of the challenges that Cam in Ottawa was telling us about in terms of connecting with vulnerable populations is the discourse in vulnerable populations is difficult to necessarily understand if you're not part of it. And what he really wanted to be able to do was to answer questions like, who in my catchment area is, I'm just going to call it at risk. And so maybe it's at risk of overdose, maybe it's at risk of homelessness, maybe it's, different kinds of things. And so there is this Ottawa subreddit that has all kinds of people discussing all kinds of things. And those users who are in that Ottawa subreddit also maybe discuss in other kinds of subreddits. And so you can kind of learn something about individual users based on the sort of what subreddits they belong to and the kinds of things that they talk about. And you also can maybe infer that if they participate in Ottawa type discussions, that they are somehow connected with Ottawa, and therefore the Ottawa Health Unit, they might be sort of in their catchment area, and they might be people that they would want to be able to provide resources to or help in other ways. So if we want to try to answer this question using, for example, Reddit data, you can imagine saying, oh, okay, well, like, let's see who posts in both /r/opiates and who posts in /r/Ottawa. And it turns out that that's a very small number of people. Like, it's a few, but it's really not very many. So that's a very coarse way of kind of trying to identify a population that you might be interested in. So what we did after that just initial quick look was to try to think about how can we use the language that people are using to, rather than just the geography tag on its own, to try to understand who's at risk. Or sorry, the participation in the opiate subreddit, you know, how can you use the language that we're using to help identify who might be at risk. And one of the first things that we ran into right away, which I alluded to a second ago, was this challenge of discourse. So I'm just going to give folks a chance to read this post, which is from the opiates subreddit. So unless you're part of this community, there is probably a lot of language here that you are not going to be familiar with. And sometimes it's individual words, and sometimes it might be phrases like cold cop, which is basically to go try to buy drugs from somebody you don't know. So there's this real challenge of trying to understand the discourse in these communities because they use an entire vocabulary and just sort of way of speaking in general that's unfamiliar. Even if you are a frontline worker in a public health unit, you might not be aware of this. And the other thing is their language is evolving very quickly. So, so what we did was we used the technique of word embeddings, which Alana talked about before, because even though the vocabulary here is different, a lot of the contextual words are still enough to build a representation that lets you sort of recognize that words are being used in a particular way. And you really need to do that because if you really do just try to do something that's keyword based, like search for FENT in /r/Ottawa, it does not show up. So the approach that we took was to take the word embedding idea, and we used a related technique that embeds not individual words, but an entire corpus of data. In particular, it's a technique that was designed for embedding a collection of documents that were all written by the same user. So the approach we take is sort of, you are your words, and so this is a Twitter user who happens to be tweeting about chickenpox, and is a collection of all of their, well, it's not all of their tweets, it's some of their tweets, to give you kind of a sense. And what we did was, in using the same concept with the word embedding, where a word would be represented as a vector in some space of some dimension. In our case, it was also kind of big, like around 300. We developed an embedding of users. I'm using Twitter as an example, but we did it with Reddit, that maps every user to a point in space. Really, it maps the discourse of every user to a point in space. And then once we have that, our point, we did what we called archetype-based search, where we embedded a user of interest, or maybe a collection of users of interest, whose discourse we thought was important for some reason. And then we compared them to a bunch of other users to try to identify the users who are most similar to the archetypes that we identified. And the reason that this was important and useful is that it's a lot easier for an epidemiologist, for example, rather than to try to think of all of the words that somebody might use that might indicate risk. Reading somebody's posts and kind of understanding their situation as it's presented on social media, but still, and then saying, okay, yeah, this is the kind of person that we want to reach out to. This is the kind of person that we are worried about. Changes the focus from keywords to people and allowed them to operate, to do this kind of searching without needing to know the vocabulary up front. So this was kind of the main, the way in which we used the techniques that Alana was talking about. And we were, so we were just about to roll this out. And actually, we were fortunate to get some funding to have a meeting with public health practitioners in, I think it was about it was supposed to be kind of mid-late March, to really push this to the next level and deploy it. But then all of my public health contacts got very busy all of a sudden. So that's on hold for now, but we're looking forward to pushing that forward, and for, you know, hopefully using this idea to support public health work as people reach out to different kinds of individuals. Okay. So that was when Alana and Rumi and I started talking about this COVID idea. One of the reasons I was excited about it is I thought it sounded like a really interesting, you know, similar but different kind of problem to what we had been looking at with the archetype-based search. And I imagine we would probably be using a lot of the same kind of techniques on the technical side. And the other reason I was excited is, so I'm not an epidemiologist, but I've been sort of embedded with them for about 5 years now, and it's starting to rub off. And so one of the things that I thought would be really interesting would be to, as we explore the technical side of this project, really think about how epidemiological principles can inform what we're doing. And in turn, how can we do analyses that are gonna be, kind of make sense to epidemiologists as well. So there's different ways of thinking about how we want to understand the relationships among different kinds of activities on Twitter and COVID and mental health. The epidemiological viewpoint is going to be thinking about person, place, and time. So I just pulled this definition from Wikipedia because I thought it was pretty good, and I edited it a little bit because, you know, it's open source license. But epidemiology is really about populations of individuals and trying to understand the patterns of diseases among those individuals, and also the determinants of diseases. And that's really important. Like, what are the factors that are leading to disease in different populations? So it's not, in particular, just outbreaks, right? Epidemiology is much bigger than that. And epidemiological principles are useful to apply when you're thinking about outbreaks, but it's certainly not the whole story. And I think that there's a lot to offer from the discipline in terms of how we think about the effects of COVID-19. And there's different ways of talking about activities within epidemiology, and I want to identify two right now. One of them, folks call descriptive epidemiology, which is sort of what is happening. It's like, you know, how is this disease distributed right now? Who tends to get it? That sort of thing. You know, what do I understand about the population that I'm interested in at the current time? So you can think of actually the project that I just talked about in terms of trying to understand where and who vulnerable populations are. It's sort of more like a descriptive epi kind of project. Analytic epidemiology, on the other hand, is really focused more on why is this happening? Why are we seeing the disease processes that we're seeing? Why are the determinants of health that we're finding, why are they determinants of health? How are they leading to health outcomes? So an example of a descriptive epi sort of question or analysis would be sort of what's the prevalence of opiate use, maybe in a population. And an analytic epi question might be, why is COVID-19 leading to poor mental health outcomes? And in this work, I think we have the opportunity to frame the analyses that we do in terms of what is the causal chain from COVID-19 to the outcomes that we're seeing. This is really tough because we don't get to do any experiments. So to really understand what causes what, if, you know, in a lot of science, what you do is you run an experiment. You change a variable and you see what happens. We don't have the luxury of doing that here because we're just sort of observing what's happening on Twitter. We're observing different events happening, but we can't necessarily, not even necessarily, we can't intervene and change things. So it's difficult for us to say, you know, what's causing what. And just because we see something happen after something else doesn't mean that it caused it, for sure. But that doesn't mean that we're sunk, because what we can do is use basically subject area knowledge to think about what are the possible causes and effects that we're interested in trying to understand, and also what are some of the mediators of the effect of that cause on that outcome. And a mediator is just another event or something that happens, or a variable that happens on the way from the cause to the effect. What some of the things that we hypothesized are mediators for mental health from COVID are things like baking, job loss, isolation, these kinds of things. So what would be really nice would be to try to understand what are these things sitting in between COVID, however that ends up being defined, and mental health outcomes. And so that's what we're going to start at the end. I'm hopeful that we're going to have an understanding of this. And an understanding of this is not going to come just from the data. I mean, nothing comes just from the data, ever. But in particular here, where we're doing a data analysis of what we call observational data, it's not experimental, and we're going to try to see what we can tell about causal links. In order to make those kinds of inferences, you have to bring in expert knowledge, existing theory about what connects to what causally in order to make those kinds of conclusions. So I'm hopeful that that's something that we can do. I'm not sure if there are any epidemiologists in the house. Hope so. Maybe we can talk after. But this kind of setup of trying to understand, there may be some direct effects of COVID on mental health. There probably are. If you get COVID, I'm sure that, you know, there actually, even biologically, there are probably effects, right? But then there are also these other effects through these other things that can happen. And so teasing those apart is one of the sort of end goals of the study. But in order to get to that point, we need to start, and we always do start when we're trying to understand causality in epidemiology, is start by looking at associations between things, because that's sort of the best that we can do to get started. Then we sort of overlay theory on top of that to try to see what makes sense causally. So this project is very fresh. We are only a couple of weeks in. We've got the data sort of cleaned up right now, and that's still sort of in progress. So I'm just going to show you a little bit of preliminary data about the kinds of things that we're seeing. This data is from Twitter. So to give you a sense of the kind of data that we're getting, it's tweets, and we've kind of got two big collections of tweets. One of them contains tweets that are have keywords associated with poor mental health, and then the other collection of tweets that we have comes from Twitter, and those tweets have COVID-related terms in them. So as an example of the kind of tweets we would have in the COVID set, here are three up there, and here are three tweets that show you yet again why language is hard. So I just kind of pulled a few tweets that had the word job in them and the word COVID, and you can see that they reflect really different experiences about COVID, employment, and the sort of what happens next. And I think actually I found three that were positive. So we're definitely going to need the full collection of techniques that we talked about before. But to give you a sense of what's been happening on Twitter to date, using just count-based methods, I wanted to just show you a few things. So here we've got time on the x-axis and posts on the y-axis, so tweets. And interestingly, we've got this downward trend in tweets related to COVID over time, which kind of mirrors actually the crisis line data. That there is this, you know, earlier on, this is a later time window than we were looking at earlier, but even so, there seems to be sort of a bit of a decrease in what's going on. And we see that there are a really significant number of tweets talking about stress in particular, and then sort of fewer tweets that explicitly talk about anxiety and depression. Oops. So this was just sort of our baseline, trying to get an understanding of what seems to be the trend in the different sorts of concepts that people are talking about over time, measured coarsely by these keywords. And the next steps that we've just started are to try to look at the relationship among indications in tweets of poor mental health with other sorts of things that are happening with folks. So what we have here is just correlations between different topics and a topic that denotes negative emotion. So it's like the negative sentiment that Alana was talking about in the previous part of the talk. And we're, for now, just with its preliminary results, we've got a collection of topics that are pre-specified. What we want to do is actually refine these into a collection that's more meaningful for what we want to look at. However, it does have sort of a collection of sort of hobbies and things. And then we have death in here to look at almost as a baseline to kind of check to make sure that it is in fact associated with negative emotions, which it is. And we're basically doing one of the first things I think a lot of us do when we're doing any kind of data science, which is to just check the basic things and look for big signals. Before you dive into fancy methods, it's always a good idea to check the simple stuff first, not just because it's easy, but because if it's effective, you probably want to stick with it. So we haven't yet seen any obvious relationship between these sorts of hobby type topics and negative emotion. All of the hobby type topics tend to be like slightly positive, which I think kind of makes sense. And then again, we have death in here really just as sort of a control to make sure that we're getting the sentiment in the direction we think we want. And just for comparison's sake, we have this lined up against incidents, coronavirus case incidents. So this is new cases per day over time. And honestly, we haven't seen too much. I will note though that one of the things that we want to do in this project is break down by geography a little bit, because we hypothesize that the kinds of trends that we're going to be seeing and the relationships that we're going to be seeing may differ by geography. So I have a graph here for Chicago that we're seeing. I have a graph here for Dallas. And it's interesting because in breaking these things down, we have started to see a few little blips here and there that we need to investigate further. And that's been sort of instructive, not just because we think there might be something going on, like strangely, all of a sudden there is a little a blip about people being maybe annoyed and cooking and restaurants. As you know, or if you have any familiarity with Twitter, a lot goes on Twitter, and a lot of varied things. And sometimes tweets can go viral and really catch on, or kind of ideas and concepts can go viral and really catch on. So one of the things that we're looking at right now is this negative association between restaurants and cooking could be to do with mask regulations in Texas, which have been extremely contentious, and there's been a lot of back and forth, and it could be that what we're seeing is that, but we don't know. We need to look a little bit more closely. And again, in other kinds of settings, we're not necessarily seeing a whole lot of signal. That we're finding shocking at this point, but again, this is really preliminary data. So maybe we can give you a more complete talk a little bit further in the future. So this is just to illustrate that the approach that we want to take is to really look for associations between these different mediators, potential mediators of mental health, exposure to COVID, and even ideas around COVID and the anxiety and everything that comes with that, and looking at mental health outcomes. And we really want to be able to break things down by time and geography because of person, place, and time being those core concepts of epidemiology. And then one of the big wrinkles that we need to figure out as we're going through this exercise is to recognize and understand when there are sort of other shocks to the system that could be causing what we're seeing. And this is the big challenge of causal reasoning in general, is we are seeing this signal, this footprint on social media. Why are we seeing it? Because there are other big events in the world that are happening that have significant effects on the mental health of individuals and can have differential effects on mental health of different subpopulations. So here's the COVID curve superimposed with the Black Lives Matters tweets curve. So nothing happens in a vacuum. All we can really do is take into account as best we can all of the possible influences that we're seeing in terms of those results on social media, and then trying to disentangle what seems to be driving what. So in terms of our sort of medium-term plans, as I said, what I'm showing you is basically keyword-based because we just got the data cleaned yesterday, just to kind of give you a sense of the sorts of things that we would be looking for. But we're really excited to be building some bespoke methods that are explicitly built to capture the relationships that we're looking for, and that are going to use the sorts of representation techniques that we talked about before that aren't going to have the limitations of keyword matching. So we'll be looking at that. And also, we really want to be able to customize the kinds of mediators that we want to look for, like baking and other stuff. And then another component of this project that is going to be really important is to accommodate the fact that different stakeholders who might make use of this are going to have very different needs. They're going to work in different catchment areas. They're going to have different populations that they're going to have mandates to care for. They're just going to have different interests. And so it's not like the end of this is going to be an analysis or a paper. It has to be something that's dynamic and that allows practitioners to really explore the data to try to find something that's useful for them, in a way that sort of keeps them safe from, making over-interpreting. So part of the project is to build a sort of interactive dashboard type system that would accommodate that. But really what I want to do is try to understand how can we best apply these principles of epidemiology, this person, place, and time aspect, to social media data to try to better understand this relationship between COVID, all the things caused by COVID, and mental health. So that is our project. Thank you so much, and be happy to take a few questions.
Excellent. Thanks, Dan. Thanks, Lon, as well. I mean, it's a fascinating project, and we really look forward to seeing the results. If folks have any sort of high-level questions, you can kind of put them in the chat. We don't have a lot of time, so we're kind of at our limit here. But just to understand the kind of the length of the project, what's the duration and kind of your sort of endpoint? You said you did kind of just started, but when will you kind of?
October.
October. Okay.
I think this is going to be going on for a while. We have funding through October, but I mean, yeah.
Okay, and
we're part of what we're planning to do is to put up a publicly accessible dashboard type
Okay. Okay.
website. And so
Yeah. So that,
we'll have to see what's feasible to do with that. That's actually kind of part of what we need to explore, but that's the hope. And we're hoping that as we do more analyses and gain more insights, that we're going to be disseminating those as quick as we can. Sorry, Alana, did you want to add anything?
great. So that was one of the questions was how can we sort of get access to your results and that sort of thing. So there'll probably be some papers and that sort of thing as well. But I mean, if there is that publicly accessible dashboard, if you could pass that our way, and we'll put it out to our members so people can take a look at that. That would be great.
Sure.
So a couple questions is just maybe in terms of how did you clean your data? Just maybe a brief description of maybe both of you in terms of there's a lot of noise out there, right? But are there sort of pre-processing or sort of data quality things that you do consider before you bring it into your routines?
Have you talked to Brent much about that recently, Dan?
I have not, other than, so Brent kind of gave us an overview that he had found a lot of the usual kinds of things that you find, like special characters or, so the tweets were not in the usual JSON format. I think some of the tweets that we had got from Twitter were not in the usual format. So it required some pretty low level reformatting, I think, to get it organized to the point where he could basically get them into a database. So
Okay.
I think he's got them in MongoDB now, I'm guessing, but I'm not 100% sure.
Right.
There's also the interesting problem that people tweet in many different languages, even within a city. Like, it's not, if you choose tweets from Chicago, you're not just going to get English tweets. So part of what we have to do is detect language.
Yeah, and one of the things Brent talked to me about just recently, like a couple hours ago, was this issue of viral tweets, and because right now the data have retweets, I think, as like individual, like if a thing is retweeted 800,000 times, then it shows up in the data set 800,000 times. And so it gets vastly overrepresented, even though it doesn't necessarily mean anything. On the other hand, if you do get a viral tweet like that, and it's about like job loss, and do you know what I mean? And people are retweeting it, then that is a signal that means something. And so it's going to take some judicious cleaning to make sure that we interpret things right.
Right. And so what percentage of daily tweets would you be using for your analysis? Are you pulling sort of the whole Tweeterverse in, or are you?
It's shocking how much data comes through these streams, and we are only getting a small fraction of
Okay.
what is actually being
shocking.
tweeted. Yeah, like I think we're at terabytes of data for like 2 weeks or something like that. And I mean, and it's just text, right? So it's not like images or anything.
Right.
You think of what Twitter must have in the scenes to handle all of that data. It's kind of remarkable.
One of the sources we're using is a curated set of COVID-related tweets that Twitter has put together, where they've identified like a bunch of hashtags and keywords and stuff, not just in English, actually. And so that's one of the collections of tweets is that. And then another collection is one that's just keyword based that we did to try to capture some, excuse me, tweets about mental health that Brent put together.
All right. And there's a question about if somebody wants to find out a bit more or get more involved in the project in some way, the way to do that would be to kind of reach out to you guys at your university positions, I guess.
Yeah, sure.
Okay, cool. So this comment about if this work does leads to the identification of trends in high-risk populations, would there be a way, or are you planning to maybe share that with local health officials, so that social services and others can intervene possibly and kind of resolve?
Oh yeah, so I would take that one step further. Like I mean, right now we are doing this without a public health person directly working with us all the time. And that's because, as you know, they're kind of busy. But like I am very loath to do any project like this without explicitly involving stakeholders from the get-go. And I have public health folks on speed dial. So like as issues arise, we can make contact with them. But I think that it's so key for any of us who are really computer science people who wade into this space to not do it alone, to make sure you have your subject matter experts, because there are so many pitfalls and so much damage can be done if you're not careful. So it's I'm so grateful for the question, because I think it's absolutely, yes, we would share it, and hope we would share it way before we actually sort of, put it out there, I would say.
Right. And there's a question about potential bias that would be in your sample tweets, and of course there's many ways to interpret that, right? I mean, in terms of the current Black Lives Matter, or biases around political issues and all that sort of stuff. So is there any bias analysis that you're able to do, or how do you recognize that, and how do you take account of that?
I mean, there's so much to talk about there. One thing that, I mean, maybe it goes without saying, but I'm going to say it. Not everybody tweets.
Yeah,
and so
absolutely.
the sort of the population that you're measuring when you get Twitter data is not everyone. And so you need to keep that in mind when you're looking through this data, that you are getting access to the people who tweet, and also what they are willing to share publicly. Those are two large caveats that you need to keep in mind when you're looking at this data.
Yeah.
Then from another angle, I would say that people in computational linguistics have become very aware recently about how biased their models can be. And there's a lot of interest in detecting that bias and trying to mitigate that bias. And they mostly looked at things to do with gender and race, and how the effects show up in our models, as well as when it's appropriate to remove those effects, and how to do that.
Mm-hmm.
Yep. And I'll say that one of the reasons why I'm really interested in taking and using an epidemiological lens for this work is that within the discipline, these biases come up all the time. Not in the context of AI and stuff like that, but in terms of, okay, these are the data I can get. These are the data I can actually observe. I can't actually do any experiments. I'm not doing randomized controlled trials. So given that that's the situation I'm in, how do I make inference in a way that is not naive to the potential for bias? So epidemiology, causal inference, and actually NLP should be really good friends, and hopefully that will be a thing that increases in the future. But that's another way in which we're going to try to guard against this. Is we're going to use this framework from the get-go. We are not going to like find correlations and just sort of publish them on a website.
Right.
That would be bad.
For sure. There was a comment about some work that was done by Stephen Thomas at Queen's, who got some good results with text analytics on Twitter, just to mention that. If you guys are aware of that and maybe incorporating some of that.
Great, thanks.
Great, yeah.
Okay.
I'm writing it down.
Yeah, me too.
All right, and then there was yeah, I think that's about all we have time for right now. Thanks so much. I mean, we could go on for an awfully long time. It's a very rich field, and I really congratulate you guys for using the technology, advanced technology for areas that's so important for society and for all of us as we get through this pandemic. So we'll be interested in seeing the results of your work, and we'll share those in the future. So
Yeah,
Thank you
so much for having us.
right.
Yeah, thanks everybody.
All right. So thanks, Lana. Thanks, Dan. Thanks, Robin, for your introductory comments around the Distress Center. Stay safe, everybody. Take care, and we will reconvene at one of our future presentations. Bye now.